Well, good evening. A moment. WhatsApp is lying here and there. Okay, let me begin. Now, today we have a different question. Okay, so the position of a rabbit along a straight tunnel as a function of time is shown below. The average velocity between t equal to 30 seconds to t equal to 50 seconds is. So, how do you find average velocity? There are many students who made lots of mistakes in this. The first thing what they did was they found out the area. Okay. So whenever in kinematics you ask any question in graph, the first thing to do is find out the area here. Just a minute. Yeah. It's connected. Yeah, that's fine. Choose my pen. Okay. So first thing they found out was what was the area. So ultimately they were not able to get it. That's the first kind of mistake I find. Second kind of mistake some students do is they find out the tangent here. They find out the tangent here and they say this height is 5 divided by 20, and as a result of it is 1/4, and hence you get the answer of 0.25 meter per second. Okay, so this is one thing. This is one thing. So they answered this D. This is one more which I got. And some students, what they did was they said, sir, we have understood everything correctly. You asked us to find out what is the average velocity between 30 and 50 seconds. 30 seconds is here, 50 seconds is here. So 30 seconds, the displacement here is, distance here is 15 meters, displacement, and 50 seconds, displacement is somewhere over here. So the difference here is 5. And thus I should get 5 meters divided by the time difference here is 50 minus 30, which is 20, which is once again 1.1/4, which is 0.25 meter per second. So some of them also got it. Majority of them, I think around 60-70 students got this answer. This is also incorrect. Okay, this option D is incorrect. Why? Let us understand this. See, a particle starts from O, it keeps on moving, its distance is increasing, displacement, I mean, let us say it starts from point O, it keeps on increasing like this. At some point of time, its velocity is increasing. Its velocity is increasing. Let me mark this point as A, this point as B, highest point as C, this point as D. Okay. Until O to A, its velocity was uniform. Let us say O to A, its velocity was uniform. So it's almost a tangent. And from A to B, its velocity, here it is constant, but this velocity is larger than this velocity. Let us say A to B here. Then B to C, it started to slow down, but still it is moving in the same direction. B to C, it is slowing down. And when it came to point C, it was momentarily at rest. See, this region. Let me choose my pen. Where is it? This particular region, it was at rest, the plateau region. And after that, that means when it reached point C, it was almost rest over here. It slowed down and it was at rest. And after that, it took a negative direction. Okay. So which means from O to A, what was O to A distance? 10 meters. 10 meters. A to B distance. What was A to B distance? 5 meters. 5 meters. B to C, once again 5 meters. Once again 5 meters. Then again from C to D, what happened in C to D? It came almost, it took a turn like this, came back to A here. Okay, from C to D. Now, so here, what was the timing here? This was at 20 seconds, and this was at 30 seconds, and this was at somewhere around 35, 37 somewhere, 37 for example, at point C. And again, at point D, it's again at 10 seconds. Point D, this is my point D, this is once again at 20 seconds. Where is it? Point D, nearly 20 seconds over here. 20 seconds over here. So this is what we can see. Now what is being asked? Average velocity between 30 and 50. Between 30 is this point, and 50. Where is 50 over here? It's 37. 50 is somewhere over here. Okay, I'll write this as 50 over here. So between this point and this point. So what should we do? We should find out average velocity is equal to displacement by time taken. True to this formula. And now what is displacement? Displacement is final position minus initial position. What was final position? Point A. Okay, so it should be XA minus, what is initial position? 30. XA, what is XA? XA minus X, what is this? We have called XB divided by time taken. Final time minus initial time, which is 20. Which should now be equal to, what is XA? XA here is somewhere around 30, 35 over here, right? No, not 35. It is somewhere over here. Where is it? It is at this point. At 30 seconds, where was it? At 50 seconds, it is at least somewhere over here. It's at this point over here. So it is at 25, 27, 28 somewhere. 28 minus. Now, at 30 seconds, where was it? Sorry, I'm making a mistake over here. XA minus XB divided by 20. At XA, what is XA here? That is a 50-second. Where is the particle? 10 meters minus at 30 seconds. At 30 seconds, where is it? This 40 is 30. At 30 seconds, it is at this point, which is nearly 15. 15 divided by 20, which should just be equal to minus 5 by 20, which should be equal to minus 4 meter, minus 1 by 4 meter per second. The right answer should be minus 0.25. Okay. So you can always say only a negative sign. How does it matter? But when it comes to physics, signs are extremely important. Okay. So therefore, stepwise calculations becomes very important. I hope you enjoyed this talk. Thank you, friends, for watching this lecture. And in the next video, we'll see some more misconceptions in physics. Thank you. If you like this video, like, share, comment, and subscribe to my channel for further updates. Thank you.